Now, when you are balancing, you need to know an order, and I want you to stop, and in a moment you're going to copy these down. To balance a chemical equation, you need to have the same number of reactants as you have products. Step 1 is you're going to start with the metals. Step 2, if there are polyatomics involved and you have the same polyatomics on the left as you have on the right, you're going to keep those together. Now I'll be explaining all of this in a moment. Next, balance the nonmetals, except for hydrogen and oxygen. Save those for last. Then we're going to balance hydrogen, and then we're going to balance oxygen. Now stop and pause and write these steps down. All right, here's an example. We have hydrogen plus chlorine, and they yield hydrochloric acid. Now we need to keep in mind that hydrogen is a diatomic, part of Hofbrinkel, so hydrogen is H2. H2 plus chlorine, chlorine again part of Hofbrinkel, so Cl2 yields, we put our arrow, hydrochloric acid. Do you remember this formula for hydrochloric acid? Hydro means that it's binary, so it starts with hydrogen. Chloric means chlorine. Chlorine has an oxidation of number of -1. Hydrogen is +1, so this is correct. Now, tricks to balancing. There are different ways to balance, but this is one easy way. If you write under the arrow the symbols for each of the elements on the left side, each of those elements should be on the right side. And then you just put little lines on both sides. Now we're going to write how many are we starting with. We're starting with 2 hydrogens and 2 chlorines on the reactant side, 1 hydrogen and 1 chlorine on the product side. These don't balance. We have to make them balance. Now we are never going to add subscripts, because then it's not hydrochloric acid anymore. All we can add is coefficients, the big numbers to the left. So I need 2 more, so I'm going to put a big 2 in front of hydrochloric acid, and now I'm going to rebalance. Still have the same on the left, but on the right we now have 2 H's, so I'm going to cross this out and put a 2. We now have 2 chlorines, because this goes with the entire thing. 2, and now we are balanced. This is a very good method to use for balancing equations. Here's another one. I want you to pause it a minute, see if you can get this. All right, we're back. Hydrogen, again, Hofbrinkel, plus oxygen yields dihydrogen monoxide. Yes, water. Okay. Now, step 1, we're going to put our elements down below. We're going to do our count. We have 2 hydrogens, 2 oxygens on the left, 2 hydrogens on the right, only 1 oxygen. So we're going to need more oxygens. So I'm going to start by putting a big 2 in front of the H2O and recalculating. We now have 2 times 2 is 4 hydrogens, 2 times 1 is 2 oxygens. Now that we've done this on the right, it's kind of messed up, doesn't balance the left. So what can we do? That's it. We're going to put a big 2 in front of this hydrogen, rebalance this side, got it. Balance everything on the left equals everything on the right. Your turn. First, on your notes, I want you don't have to write the words, but I want you to try writing the formula for this. Pause and write the formula. Okay, this is what you should have. You should have iron plus fluorine, and you need to remember fluorine is a Hofbrinkel, so you can put F2, and it yields iron 3 fluoride, and if you remember, for my ionic bonding unit, this is going to be FeF3. Now, I'd like you to complete the balancing of this equation yourself in your notes. We'll be checking this. You can pause and balance your equation. All right. Next, we are going to do another one. Sodium plus magnesium iodide. Again, this is what I'd like you to do. This is going to be your formula. Sodium. And if you remember, we need to drop and swap. So you're going to end up with magnesium iodide yields sodium iodide. Do we need to drop and swap this? No, we don't. This is Plus 1, minus 1, so we're good here, plus magnesium. Now I would like for you to balance this equation. Again, we'll be checking this in your notes. So pause it, balance it, then press start again. All right, next we're going to be talking about polyatomics. If you have a polyatomic on the left, for instance, we have this OH here, and it stays the same on the right, all you have to do when you are writing your symbols below your yield sign, keep your polyatomic as one unit. We're not going to separate the O's and the H's. It makes it a whole lot easier when you're balancing. Now you can only do this if the polyatomic is the same on the left as it is on the right. Again, we have 1 Fe, 3 Cl's, 1 Na, 1 OH. On the right, 1 Fe. Go down here, we have 3 OHs, 1 Na, and 1 Cl. This one's rather easy. What I want you to do, again, balance this one, put it on your notes. All right. Next, again, we have a polyatomic here. CrO4 on one side, CrO4 remains on this side. So we have lithium, CrO4, Ba, and Cl. We are going to count our elements. You're going to copy this on your paper, and you're going to be doing this one yourself as well. 2 lithiums, 1 CrO4, 1 Ba, 2 Cls. On the right, 1, 1, 1, and 1. Continue until this is balanced. Write your reaction on your notes.